Hey y'all, hope you're having a good day. Today we're going to take a look at how to balance a redox reaction in a basic solution. So again, we see we have our general redox reaction there. We're being told that it's in a basic solution, and now we have to balance it. Again, remember the big difference between an acidic and basic solution is that in a basic solution we would have predominance of our hydroxide ion or OH minus, all right? And so now that being said, we're going to make our lives easier with how to balance this. And so to do that, we're going to start off by balancing this exactly the same way as we learned yesterday and balance it as if it was in an acidic solution. So we're going to follow all those same steps exactly until we get the final overall, right? So the first thing we're going to do is break it down into our half reactions. So we see we have CH3OH going to HCOO minus, and then our MnO4 minus going to our MnO2. All right, and so I'm going to work with the top equation first, and then I'll go down to the bottom, right? And so now, again, the second step, or first step would be balance those atoms other than hydrogen and oxygen. We see the carbons are already balanced, so now we have to balance our other ones. So we're going to have to add an H2O here to the left, and when we do that, we see that we end up with 6 H's on the left, so now we have to put our 5 H pluses over here to balance those out. Now we have to balance the charges, and that's going to end up with 4 electrons here. Okay, now we have to balance the other one. Okay, and so to do that, again, our MNs are balanced, so we need to add 2 waters to the right side, and that causes us to have to add 4 H pluses over here, and now we have to balance our charge. So we have really a +3 on the left, a 0 on the right, so we're going to have to add 3 electrons over here. So now our reaction should be balanced, or half reactions. Now we're going to have to do what we did before. And so we look here, we're going to have to, in order to get those electrons to balance out, we're going to have to multiply the top one by 3 and then the bottom one by 4. So I'm going to switch colors. And so for this, that would give us 3 H2Os plus 3 CH3OH going to 3 HCOO minus plus 15 H pluses plus 12 electrons. Okay, and down here, we would see that we would have our 12 electrons plus 16 H pluses plus 4 MnO4 minus going to Mn, there's a 4 in front, O2 plus 8 H2Os. Okay, and so again, now we're going to add those up, and I'll do that in green. And so my electrons will cancel, right? That's the big thing. We need those to cancel out. That's why we multiply through. Now we can look at our thing. So we have 15 H pluses over here. We have 16 over here. So now we have 1 left there. We have 3 waters here. We have 8 waters here. So that would give us 5 there. And so now if we look, everything should be canceled. So we're ended up with an H plus my 3 CH3OHs plus 4 MnO4 minus going to 3 HCOO minus plus 4 MnO2 plus our 5 H2Os. Okay, and so now if we were in an acidic solution, we'd be done. We're like, woohoo, done, balanced. There we go, but we're not. All right, and so now what we have to do is go to step 2 here. And so now we're going to get rid of the H plus because we're in that basic solution. So now we want to both sides of the reaction add a number of OH ions that is equal to the number of H plus ions in the reaction. So now we see we only have 1. So over here, I'm going to add an OH minus. But what I do to one side, I have to do the other. So I'm going to add that OH minus here. Now I put it underneath the H plus over here because the next step is here, cross out the H plus and the OH ions that occur on the same side and replace them with an equivalent number of water molecules. So if I have an H plus and an OH minus, hopefully that makes sense that it becomes an H2O, right? And so those things go away, and now I have this. And so I did that. I can't do anything on the other side. And now finally, I'm going to cancel out any water molecules from opposite sides of the reaction to get the overall net, right? So that's the last thing now I need to cancel. And so if I look here, right, I have that one H2O that I just formed here, and I had 5 over here, and that's going to become 4. And so what I need to be able to do then is to just rewrite this net ionic. And so now I'm going to have 3CH3OH plus 4MnO4 minus going to 3HCOO minus plus 4MnO2 plus 4H2O plus my OH minus that I added there at the end. All right, and so if we look at this, they everything should be balanced, atoms and charges alike, if I did it correctly. And so for a -4 on that side, -4 on that side, and we can go through the atoms, but I'm pretty confident that they're balanced. Okay, so this right here would be our final thing. So again, doing exactly like we did yesterday, and then once we have that balanced overall, we're going to get rid of the H pluses by adding in those OH minuses. All right, work the couple practice problems that you have there, and then reach out if you have any questions. All right, guys, I hope you have a great day. Peace, love, happiness. Thanks for playing.